This video will be about adding and subtracting matrices. So when you add or subtract a matrice, the two different matrices must be the same size or else you cannot add them together. Because when you add and subtract matrices, you only add and subtract the corresponding elements. So if we had matrix A and matrix B, so A is a 2 by 2 and B is a 2 by 2. They are the same size, so we could add these together. We can do matrix A plus matrix B. So if we're doing A plus B, we add the corresponding elements together. 1 is in the top left corner. This is element 1, 1, because it's in the first row, first column. -3 is also in the top left corner of matrix B though, so first row, first column of matrix B. We add those two together. So for our answer matrix, 1 plus -3 is -2. Those corresponded, we add them together. -3 is top right corner, 4 is top right corner, so we add those together. -3 plus 4 is +1. 2 is bottom left, 0 is bottom left, 2 plus 0 is 2, and 5 is bottom right, -2 is bottom right, 5 plus -2 is 3. So when you're adding and subtracting, they must be done in corresponding order. 1 plus the -3, you have to make sure your elements are corresponding to each other when you add them together. So an example of something that could not be added together, if matrix A was -2, 5, 3, 7, 1, 2, and matrix B was -3, 1, 5, 7. Well, matrix A is a 3 by 2 matrix. We have 3 rows, 2 columns. Matrix B is a 2 by 2 matrix, 2 rows, 2 columns. Those sizes don't match. If the sizes don't match, we can't add. So subtraction will be similar. You have to have the same size matrices, but you do have to watch out for one thing when you do your subtraction, and that's how the negative, the minus, will be affecting what you do. So let's say we are subtracting these two matrices. So we have 5 and -3. Those are in the corresponding spots. But this time we are minusing. So we have 5, and then we're subtracting a -3. So when you have a minus next to a minus, so if you have minus -3, that's the same as just adding. 5 minus -3 is the same as 5 plus 3, so this one will be 8. So you do have to keep in mind that this negative will interact, or sorry, this minus will interact with this negative and make it just plus. We can do our -2 minus 4. That would give you -6. We did not have minus a negative here, so we don't have to change to plus on that one. Oh, I skipped over. Let's do 0, 2. We're minusing. 0 minus 2 is -2. You don't have to write the workout. You can just do it in your head. This is just to show that you do have to be super careful with the minus and the negative sign. Next, we have -3 minus -6. So here it's happening again. We have minus a negative number. So that's the same as -3 plus 6, which is +3. Then we have -1 minus 0, which is just -1. And we have 7 minus -2. Again, that would change to one big plus sign, so it's just 7 plus 2, or 9. So be careful when you're subtracting that you make sure to watch out for those minus a negative number, because it really changes to plus. So now that we know how to add and subtract matrices, we can actually solve what's called a matrix equation. So when you have a matrix equation, you are solving for a variable x, but instead of just numbers being part of your equation, you have matrices as part of your equation. So an example of an equation that's non-matrix, just to remind how we solve equations. If I had an equation like this, x minus 3, my opposite is to add 3. So I did my opposite to cancel that out. 5 plus 3 is 8. Well, it's a similar idea here. We want to do the opposite. We're minusing this whole matrix, so the opposite would be to add this whole matrix. But when you work with an equation, what you do to one side of the equal sign, you have to do to the other. So we're also adding over here. And then the opposites cancel each other out. You're just left with x only on the left side. And on the right side, we've got to actually add the corresponding elements together. Negative 4 plus 3 is negative 1. 1 plus 5 is 6. 7 plus negative 1 is 6. And 3 plus 2 is 5. So with our matrix equations, they can switch it up a little bit and change the order around. This one we were subtracting, so we had to do the opposite of addition. But let's say we have this matrix equation. So here's our matrix equation. So this time we're adding, this is really a positive. They don't write the positive in front, but there's really a plus sign in front here. So we're adding to our variable x, so our opposite would be to minus this matrix. Same thing on this side, we're minusing. And so when you're doing your subtraction, you've got to watch out for any minus minus. We have 4 minus negative 2, that's actually the same as 4, plus 2, so 6. 0 minus 3 is negative 3. Negative 1 minus 5 is negative 6. Negative 3 minus 1 is negative 4. 7 minus 0 is 7. And 2 minus negative 1, there's our minus negative again, so 2 plus 1 is 3. And if you're ever confused, write your work to the side. Say, well, I know 4 is top left. I'm subtracting. Top left of the bottom matrix is negative 2. So 4 minus negative 2, oh, that's the same as 4 plus 2, which is 6. So you can write your work to the side if you're having trouble just doing it in your head as you go through the subtraction. So one last type of matrix equation to talk about. Let's say we have a matrix equation that looks like this. 3, negative 5, 0, negative 6, 4, negative 1, 6, 4, minus x. That minus sign is going to make a big difference. Equals negative 2, 4, 5, 8, negative 2, negative 7. So we are still actually going to do the opposite of subtraction first. Yes, there is a minus x here, but the matrix itself is a plus. Whatever is in front is what we're working with. So when it's the first thing, they don't write the positive here. We have to know this is really a positive matrix. So our opposite will be to subtract this matrix. And what you do to one side, you have to do to the other. And since it was a positive, we didn't interact with that minus, the negative x will come down. It's not just an x. If it was positive, we can bring just the x. If it's negative, we've got to do the negative x. We've got to subtract. Negative 2 minus 3 is negative 5. 4 minus negative 5. Got that minus minus going on, so 4 plus 5 is 9. 5 minus 0 is 5. 8 minus negative 1, minus minus is plus again, so 8 plus 1 is 9. Negative 2 minus 6 is negative 8. And negative 7 minus 4 is negative 11. Now the problem here is we have a negative x. We want this to be a positive x. So in order to change this to be positive, we want to switch this from a negative to a plus. We're going to have to change every sign in our matrix itself. This is a positive 5 now, negative 9, negative 5, negative 9, positive 8, positive 11. So if we change the sign over here, we've got to change the sign of everything over here. So we get x equals positive 5, negative 9, negative 5, negative 9, positive 8, positive 11. And that will give you your final answer. So that's all we need to know about matrix equations. They may also ask you about identifying two matrices or matrices that are equal, or finding unknown elements inside a matrix. So when they ask for two matrices, if they are equal matrices, they're usually just going to have some things inside that you could change or simplify. So like for this one, you can take the square root of 16. The square root of 16 will be 4. Negative 2 is as simple as it can be. You can't change anymore. 3 divided by 4 you can change. 3 divided by 4 would be 0.5. You would plug 3 divided by 4 into a calculator, and it's going to give you the corresponding decimal. Now they may go the other way. They may give you a decimal and say, what's this as a fraction? So to change a decimal to a fraction, we look at the place value. 2 is in the tenths spot. Right after the decimal is the tenths spot. So that means this is 2 over 10, the fraction. This can reduce. Both the 2 and the 10 divide by 2. So this will become 1 over 5 as its simplified fraction. So they may ask you to do that, to just identify which of these match up. Usually it'll be multiple choice, so you'll have a couple of options, and you want to look for the ones that correspond. Or the last thing they will ask is finding an unknown element. Let's say we have some variables inside our matrix. And they're going to give you these two matrices equal to each other. And they're going to ask for a specific variable. So if they ask for the value of W, is the value of W. We're going to look for where W is. It is the top right-hand corner of this right side matrix. You have W plus 1. It's just going to equal the corresponding element in the other matrix. It will equal the negative 6. So now we have a basic equation to solve. W plus 1, we'd have to minus 1 to do the opposite. So W would equal negative 6 minus 1 is negative 7. And they could ask you for any variable. Let's say we want x instead. Then we take the 2x and set it equal to its corresponding piece, which is the 12. 2x equals 12. To solve this, we have to know that this is really 2 times x. Opposite of multiplication is division. So you divide by 2, then 12 divided by 2 is 6. So you can find any variable they ask for, even if, so like the z, if they asked for z, z corresponds to 4. There's no actual solving to be done. Once we have identified they correspond, since z was already alone, z is just 4. So that concludes our discussion on addition and subtraction of matrices.